Good morning, Pre-Calc, and welcome to applying the six trig ratios. So here's to do now. Hopefully you saw this in class already and you've done this, but if not, hit pause and work through these problems. And so in number one, we've got some parallel lines cut by a transversal, and so some of these angles are going to be congruent to one another, and some of them we can subtract from 180 because two angles making up a straight line are always going to add up to 180. So angle number one is 129. Angle number two is going to be parallel, or is congruent to that because of the parallel lines. And then angle three is going to be the 51 degrees, be congruent to the 51, or we could subtract from 180 again. Number two, in order to solve for x, since the variable is in the denominator, we have to multiply both sides by x and then divide by 5. The various different applications, cross multiplying, and some other approaches that people use are totally fine. We end up at 3/5 or 0.6. You cannot do on number two the same thing that you would do on this hidden problem number 3 down here, which is just to multiply by 3. That would work only if the variable is in the numerator. If we got x divided by 3 equals 5. This problem would be equal to 15, but since the variable is in the numerator, it makes this not the same as what we saw in problem number 2, where it was 3 divided by x. So a couple of quick comparisons between these two solve for x problems. In solve for x number 3, where the variable was in the numerator, it took us one step, only one algebra step to solve that. And when we had the variable in the denominator, it took us twice as much work, 2 steps. We had to multiply by x and then divide by 5. Is that a huge deal? I mean, no, but it is twice as much work. Certainly, we have the algebra skills. We could do this either way, but bear that in mind for just a minute. Okay, so the goal for today is we're going to take those 6 trigonometric ratios that we learned about yesterday and apply them to find unknowns. It's the 6 trig ratios I'm referring to, sine, cosine, and tangent, along with their reciprocals that we saw yesterday, cosecant, secant, and cotangent. So we're going to hit a couple of vocabulary words first. As far as measuring angles goes, in application problems or word problems, story problems, whatever you want to call them, we often have angles that we measure where we're going up. We call those angle of elevation or angle of incline or any other kind of synonym for that that implies some sort of upward motion. And if it's a downward angle, we call it an angle of depression or angle of decline. Or again, there's lots of synonyms for that. The important thing is the bold letters down here in green. Any of those angles are always going to be measured from the horizontal. So in either of these little stories, if you're looking up at Mount Rushmore, draw an imaginary invisible line straight sideways out of your eyeballs, and that is the line we're going to measure the angle from, whether you're looking up at an angle of elevation or whether you're standing at the top of the cliff looking down at the boat below you. Always measure from the horizontal. Measuring from a vertical reference line is possible and it is done on occasion. It leads to a lot of problems, and so we avoid that. Um, Even if you're given a reference angle measured from the vertical, we're always going to do our little geometry application to get the angle measured from the horizontal. Okay, let's do an example problem. The lighthouse in Barnegat Bay is 210 feet tall. The lighthouse keeper sees a boat out here in the bay floating in the water, and angle of depression to the boat is 25 degrees. So we're going to look straight horizontal, see nothing. It's just blue sky and blue water out there. So if we turn our heads down, 25 degrees, we're looking right at that boat. The lighthouse keeper wants to make sure that the boat doesn't get too close to the deadly Barnegat Bay rocks at the base of the lighthouse, because the little boat would be smashed to math bits. So we want to find out how far away from the lighthouse is the boat. So the first question is we're going to find out what angle would the boater have to look at to see the lighthouse keeper. And if you said 25 degrees, you're right. It's going to be the exact same angle because we do have parallel lines. The horizontal line here, that we're measuring that angle from, coming straight out of the lighthouse keeper's eyeballs, is parallel to the surface of the ocean, at least the way we draw it. And then we got a transversal line, so we have alternate interior angles. Both can be 25 degrees. So I'm going to work from the triangle here from the perspective of the boater. The reason for that is just because it makes a more natural triangle. I've got one side is the lighthouse. I got one side is the ocean. The way the picture is drawn, it totally fits my diagram. You could do it with, your invisible triangle drawn into the air, going straight across the sky. If you wanted, there'd be nothing wrong with using this triangle. There we go. A red one, you could totally use that. It's going to end up the same. I just like to have my triangles on the ground. That way they don't fly off and do weird things. Right, okay. So the sides that we are concerned with are going to be the height of the lighthouse, which is given to us in the problem. That's 210 feet tall. And the length of the bottom side. That's the distance from the boat to the base of the lighthouse. Call that X, or whatever you wanted to call it. So from the perspective of the boater, since that's the triangle I decided to work with, I'm going to name the sides of the triangle. So I have opposite side over here, that's the lighthouse. I've got an adjacent side, that's the surface of the ocean. The hypotenuse, I do not care about. The hypotenuse has absolutely no place in this problem because that is not a distance I need to find. Right? The boat is not going to fly up out of the water and crash into the top of the lighthouse. So the hypotenuse, other problems maybe we pay attention to, but here I do not need. So I'm going to choose which trig ratio I need based on the sides that I know, opposite, and the side I want to find, adjacent. I know that opposite and adjacent is tangent. So I could set up my trig ratio, tangent of 25 degrees equals the opposite side over the adjacent side. So it's going to be 210 over x. And at this point, I'm going to point out that while it is possible to continue with the trig ratio tangent set up as it is, I have the variable in the denominator. And I know that means it will take me twice as much work to solve for x as if the variable were in the numerator, just like we saw back here in the do now, right? Can we handle it both ways? Yeah, we have those algebra skills, but if I've got the choice of setting it up a long way or setting the problem up to do it a short way, I would rather just do it the short way. So I'm going to not use tangent. Actually, I'm going to use the reciprocal trig ratio because I know those now. So I have two choices here. Tangent and cotangent both use the opposite and adjacent sides. The tangent ratio is going to give me x in the denominator, that's the adjacent. Cotangent would give me x in the numerator, that's the adjacent side. I would much rather have my variable in the numerator, so I'm going to use cotangent. Cotangent is adjacent over opposite. All right, so I'm just going to cotangent of 25 degrees is x over 210. And then I am going to have to calculate what is cotangent. All right, well, on my fancy dancy calculator, which is really not all that fancy dancy, I have, if I type in my 25 degrees, I go to my tangent, my trigonometry menu, I have a cotangent button, which, wow, that's awesome. I just hit cotangent and there it is. It's 2.14. I'm going to go to two decimal places, so 2.14. But most calculators don't have cotangent buttons, and so here is what you would need in order to get cotangent on your calculator. It's going to save you an algebra step. It's going to cost you an extra button push on your calculator. So you're going to do tangent. Let me start over. So I'm going to put my 25 in here. If you don't have a cotangent button, like most Texas Instruments calculators, graphing calculators, they have all these other features, and the reciprocal trig functions are not among them usually. So do tangent. Okay, you can see I got a different answer here. And then I'm going to have to do the reciprocal. So on your calculator, the reciprocal button is going to look either like 1 over x, or it's going to be the x to the -1 power button. Right, so in my calculator, it's right here. It's that 1 over x. Most Texas Instruments calculator is going to be x to the power of -1. Click that. There's your extra button push on your calculator. Still got the same result. It's 2.14. All right, so in order to finish my algebra, to solve for x, I'm going to have to multiply both sides by 210. So x is that 2.14 multiplied by 210 feet to get 450.35 or 50.35 feet. Feet. There it is. Okay.